An electrician responded to a call regarding a faulty neutral connection in a ceiling-mounted air handler, which resulted in an arc flash and power outage in a small restaurant. The initial investigation focused on a loose neutral connection in the panel serving the suite, but tightening it did not resolve the issue. Further examination of the main service revealed a chaotic wiring situation due to multiple remodels and a significant presence of spiders. Heaters were looping between sections and entering the top back of our metered sections, making it difficult to trace circuits and identify the correct neutral connections. The electrician began to suspect hidden junction boxes with bad splices, but found no immediate solution. Upon counting the landed neutrals versus the number of meters in the 4 6-meter sections, a missing neutral was discovered. The missing neutral was identified as the 3/0 neutral conductor for the 200 amp panel serving the affected suite in a multi-tenant commercial building. It had been taped up and hidden behind cobwebs and bus bars. It was surmised that during a previous remodel, someone added a meter base but lacked a suitable lug for the neutral and took the neutral from the suite. Subsequently, the suite was occupied, and an erroneous grounding of a number 10 neutral in the air handler provided a path for potentially 200 plus amps to flow through the air handler's frame and branch circuit grounding. The restaurant had been operating in this hazardous condition for approximately 1.5 years. Firstly, a loose neutral connection in the air handler triggered the initial arc flash incident. Secondly, the absence of a proper neutral connection in the main service panel due to theft. Thirdly, the accidental grounding of a neutral conductor in the air handler provided an unintended path for high current to flow through its frame. Fourthly, the complex and inaccessible nature of the feeder wiring complicated the troubleshooting process. This incident underscores the critical importance of several key aspects of electrical safety and maintenance. 1. The necessity of proper neutral connections to prevent arcing and other electrical hazards. 2. The importance of accurately accounting for all landed neutrals in electrical panels to ensure that no circuits are left without a proper return path. 3. The need for thorough inspection and testing of electrical systems, especially during and after remodels or renovations, to identify and correct any potential issues. 4. The potential dangers associated with unauthorized or improperly performed electrical modifications, which can create hidden hazards that may not be immediately apparent. Even seemingly minor electrical issues can have significant consequences if left unaddressed. It is essential to meticulously trace circuit paths in complex electrical systems to identify potential problems and ensure that all connections are secure and properly grounded. All electrical work should be performed by qualified professionals who have the knowledge, skills, and experience necessary to identify and correct potential hazards. Regular electrical inspections and maintenance can help prevent electrical hazards and reduce the risk of accidents, protecting both property and occupants. In this specific scenario, the combination of a missing neutral and an erroneous grounding created a dangerous situation that could have resulted in a fire or other serious incident. The missing neutral disrupted the normal flow of current, causing voltage imbalances and potential overloading of other circuits. The accidental grounding of the neutral provided an alternative path for current to flow, but this path was not designed to carry such a high current, leading to overheating and potential arcing. The situation was further complicated by the chaotic and inaccessible nature of the wiring, which made it difficult to trace circuits and identify the root cause of the problem. The electrician's persistence and attention to detail were crucial in uncovering the missing neutral and resolving the issue. This incident serves as a reminder that electrical systems should be treated with respect and that even small mistakes can have serious consequences. Regular inspections, proper maintenance, and qualified electrical work are essential for ensuring the safety and reliability of electrical systems in all types of buildings. Furthermore, the situation underscores the need for clear and accurate documentation of electrical systems, especially in commercial buildings with multiple tenants. When electrical modifications are made, it is important to update the electrical drawings and panel schedules to reflect the changes. This will help ensure that future electricians can easily understand the system and identify any potential problems. In addition to the technical aspects of the incident, there are also ethical considerations to keep in mind. The person who stole the neutral lug created a dangerous situation that could have had serious consequences for the restaurant and its occupants. Electrical work should always be performed with integrity and a commitment to safety. Shortcuts and unauthorized modifications can put people's lives at risk. The incident also highlights the importance of communication and coordination between different trades. The air conditioning technician who initially discovered the problem did the right thing by reporting it to a qualified electrician. It is important for all tradespeople to be aware of potential hazards and to communicate effectively with each other to ensure that work is performed safely and correctly. In conclusion, the arc flash incident at the restaurant was the result of a complex set of factors, including a missing neutral, an erroneous grounding, and chaotic wiring. The electrician's thorough investigation and attention to detail were crucial in uncovering the root cause of the problem and preventing a potentially serious incident. The incident underscores the importance of proper electrical work, regular inspections, and clear communication to ensure the safety and reliability of electrical systems. When dealing with electrical panels, it is crucial to follow safety precautions to prevent accidents. Firstly, always de-energize the circuit or equipment before working on it. Use appropriate lockout-tagout procedures to ensure that the circuit remains de-energized while you are working on it. Secondly, wear appropriate personal protective equipment including safety glasses, gloves, and insulated tools. Thirdly, inspect the electrical panel for any signs of damage such as corrosion, loose connections, or damaged insulation. Fourthly, use a voltage tester to verify that the circuit is de-energized before touching any wires or components. Fifthly, never work on electrical panels in wet or damp conditions. Sixthly, be aware of the potential for arc flash and take appropriate precautions to protect yourself. Seventhly, if you are not qualified to work on electrical panels, do not attempt to do so. Call a qualified electrician. When dealing with loose connections, it is important to address them promptly to prevent potential hazards. Firstly, loose connections can cause overheating, which can lead to fires. Secondly, loose connections can cause voltage drops, which can affect the performance of electrical equipment. Thirdly, loose connections can cause arcing, which can damage electrical components. Fourthly, loose connections can create a shock hazard. Fifthly, to fix a loose connection, first de-energize the circuit. Then tighten the screw or terminal that is loose. Make sure that the connection is tight but not over-tightened. Finally, inspect the connection to make sure that there are no signs of damage. When identifying a stolen neutral in an electrical system, it is important to take several steps to ensure safety and proper functionality. Firstly, visually inspect the neutral connections at the main service panel and sub-panels to confirm that all circuits have a dedicated neutral conductor. Look for any signs of missing, cut, or disconnected neutrals. Secondly, use a multimeter to measure the voltage between the neutral and ground at various points in the electrical system. A reading significantly above 0 volts can indicate a missing or compromised neutral. Thirdly, perform a load analysis to determine the current flowing through each circuit. If the neutral conductor is missing, the current will attempt to return through other paths, such as ground wires or other circuits, which can cause overheating and damage. Fourthly, trace the neutral conductors back to their source to identify any points where they may have been disconnected or rerouted. This may involve opening junction boxes and inspecting wiring connections. Fifthly, consult with a qualified electrician to assess the situation and recommend appropriate corrective actions. This may involve installing new neutral conductors, rewiring circuits, or upgrading the electrical panel. It is important to address the stolen neutral issue promptly to prevent potential hazards such as electrical shocks, fires, and equipment damage. When troubleshooting chaotic wiring, there are several steps to take. Firstly, start by visually inspecting the wiring for any obvious signs of damage, such as frayed wires, loose connections, or corrosion. Secondly, use a multimeter to check the continuity of each wire. This will help you identify any breaks or shorts in the wiring. Thirdly, label each wire with a unique identifier. This will make it easier to trace the wiring and identify any problems. Fourthly, create a wiring diagram. This will help you understand how the wiring is connected and identify any potential problems. Fifthly, use a wire tracer to trace the wiring. This will help you identify the path of each wire and locate any hidden connections. Sixthly, if you are not comfortable working with electrical wiring, consult a qualified electrician. When investigating an arc flash, there are several steps to take to determine the cause and prevent future occurrences. Firstly, gather information about the event, including the location, time, and any equipment involved. Secondly, examine the equipment for signs of damage such as melted or charred components. Thirdly, inspect the wiring for loose connections, damaged insulation, or other defects. Fourthly, analyze the circuit protection devices such as circuit breakers and fuses to determine if they operated correctly. Fifthly, review the electrical system design and maintenance records to identify any potential weaknesses or areas for improvement. Sixthly, consult with qualified electrical engineers and safety professionals to conduct a thorough investigation and recommend corrective actions. Seventhly, implement measures to prevent future arc flashes such as improving worker training, upgrading equipment, and enhancing safety procedures. When dealing with multi-tenant commercial buildings and electrical systems, it is important to adhere to certain best practices. Firstly, maintain accurate and up-to-date electrical schematics and panel schedules. This ensures that all electrical circuits are properly documented and can be easily traced for maintenance and troubleshooting purposes. Secondly, conduct regular electrical inspections to identify potential hazards such as loose connections, damaged wiring, and overloaded circuits. Thirdly, implement a lockout-tagout program to ensure that electrical equipment is energized before any maintenance or repair work is performed. Fourthly, provide adequate electrical capacity for each tenant to prevent overloading of circuits and equipment. Fifthly, install surge protection devices to protect sensitive electronic equipment from voltage spikes and surges. Sixthly, ensure that all electrical work is performed by qualified and licensed electricians in accordance with local electrical codes. Seventhly, maintain clear communication with tenants regarding electrical safety and maintenance procedures. When it comes to electrical safety, the NEC or National Electrical Code provides comprehensive guidelines and standards. Firstly, Article 90 of the NEC covers the purpose, scope, and enforcement of the code. Secondly, Article 100 defines essential terms used throughout the code. Thirdly, Chapter 2 addresses wiring and protection, including requirements for overcurrent protection, grounding, and wiring methods. Fourthly, Chapter 3 covers wiring methods and materials, specifying the types of cables, conduits, and raceways that are permitted for different applications. Fifthly, Chapter 4 deals with equipment for general use, including requirements for receptacles, switches, and lighting fixtures. Sixthly, Chapter 5 addresses special occupancies, such as hazardous locations, healthcare facilities, and places of assembly. Seventhly, Chapter 6 covers special equipment such as electric signs, elevators, and electric vehicles. Eighthly, Chapter 7 addresses special conditions such as emergency systems, fire alarm systems, and communications systems. Ninthly, Chapter 8 deals with communication systems, including telephone, data, and CAT-TV systems. Tenthly, Chapter 9 contains tables and examples that are used to apply the code requirements.